Schoner makes the claim that if n is an even positive integer greater than 2, this implies that 2 to the power of n minus 1 is not prime, and we get to prove this for 4 marks. We'll start out with the fact that if n is even, then this means that we can write n in the form 2 times another letter, 2 times m, for example. Moreover, if we are given that n is greater than 2, this must mean that m must be bigger than 1, because then n will be bigger than 2. Now we're going to consider 2 to the power of n minus 1. So if we replace the n with 2 times m, then we're going to get 2 to the 2m minus 1. Now looking at this is the hard step, working out what to do next. But if we use our laws of indices and rewrite this first term, then you might notice that this is a difference of 2 squares. And that means that we can write it in the form of 2 to the m minus 1 in one bracket and 2 to the m plus 1 in another bracket. Now prime numbers don't have any other factors other than 1 and themselves. So if it's written as a product of 2 brackets, if this were prime, one of these 2 brackets would be equal to 1. In our case, it's going to be the smaller one. So 2 to the power of m minus 1 would have to be equal to 1. And if we follow this working through to find m, we'll just see that this isn't true. So we can add 1 to both sides. 2 to the m is equal to 2. This means m is equal to 1. We've already said above that m has to be bigger than 1. So this gives us our idea why it's not true. So what we can now say is that because m is bigger than 1, then this bracket, 2 to the m minus 1, must be bigger than 1. And the second bracket is bigger than the first bracket, so this must also be bigger than 1. So we have a product of 2 numbers, both of which are bigger than 1. So to conclude, we can say that 2 to the power of n minus 1 is a multiplication of 2 numbers, or 2 integers, both of which are bigger than 1. And this is the exact definition of being a composite number, i.e. not being prime, because they've got some other factor in there. If you enjoyed that, I'm sure you'll enjoy these too.